All right, I want to welcome everybody to today's Technical Communications Trifecta presentation. We're presenting three products that complement SolidWorks very well, and each of them individually accomplish different tasks for the downstream user. So we wanted to make you aware of the capabilities that these tools have, and I'm going to demonstrate a few of them actually live as well. But in each area, once again, there's a different discipline or a different downstream user in mind, and we just want to show you that things that you create in SolidWorks definitely have a life outside of just the CAD system and can benefit anybody within your company, not just the engineers and designers. So first I wanted to get started here and just mention who I am. So who's your presenter? My name is Darren Gross. I've been with DASI Solutions since 1997. When I started, we had 3,000 SolidWorks users worldwide, and we are currently over the 3 million mark as of this year. So it's been quite a bit of growth, and that growth is 100% attributed to you guys. Our customers are the lifeblood of our company, and we couldn't do it without you. So thank you very much. I've had a long career, and I plan to be here a lot longer. Back in 2000, I was the Model Mania champion, the first time it was ever done at SolidWorks World, and won again in 2008. We've actually got a lot of technical staff at DASI Solutions that has won the Model Mania contest, so quite a few people there. And I'm a husband and father of two girls, an 8-year-old and a 6-year-old girl, and we have 11 chickens. So a little side note there, we have 10 more coming in just about a week or so. So it's going to be an exciting April if we can get rid of this snow. If you'd like to get more content like this or see some of the things that we're posting, you can follow me on Twitter or you can follow us on our YouTube channel. And you'll get a lot of great content. We're putting out stuff fast and furious, so please feel free to follow us. So today's Technical Communications Trifecta is going to be boiled down to these three tools here. We have SolidWorks Composer, which is a tool for creating interactive data animations and technical illustrations and service guides utilizing your SolidWorks content. SolidWorks Model-Based Definition, which is a new way to think about communicating within your organization, as opposed to the traditional methods that we employ today. And then SolidWorks Inspection. We know several of you out there create inspection reports which include ballooned versions of SolidWorks drawings, as well as the Excel spreadsheets that are required for each of those. So those are the kind of things that, that inspection is really perfectly suited for. So we're going to start with SolidWorks Composer, and I'm experimenting a little bit with the way we present here, so I thought I'd bring myself up on the webcam here for just a little bit. And basically, we're going to cover each of these products individually, and I'm going to show you as many things as I can about each of them. But really, if you need to take a little bit of a deeper look, please feel free to get a hold of us, and we'll do either an online meeting or demonstration for you. But for SolidWorks Composer, what we're first really talking about are these four areas here. SolidWorks Composer is great for capturing what you've done in CAD and creating some nice views and descriptive information through views and animations. The animate portion is a great way to do things because pictures are great, but animations show things visually. They have a universal appeal to them. When you change things in the CAD system, a big challenge for everybody out there is in the current methods that you create documentation, which usually relies on a lot of screen captures or actual digital photographs. Changing something is more or less a do-over, and I want to show you that that is not the case when we're using Composer. And then how we produce these files. Really, it's more of your downstream consumer in mind, but there are many ways to save and deploy this data. So let's just start out with the first aspect here, which is our capturing tools. Now, when we're talking about this, we really first start with the CAD data in SolidWorks. So as you're looking at an assembly that you've created, the colors that you've used for parts, different things that you've used for features, even the hierarchy of an assembly and subassembly structure, all of that information transfers directly over to Composer. When you're in SolidWorks Composer, which is a standalone application, doesn't tie up your SolidWorks license and really is suited for not necessarily the engineer or the designer, but for the direct marketing or tech pubs person within your company. It's a simpler software to use. It doesn't take quite the computer resources that SolidWorks does either. But essentially, they open up those files directly from SolidWorks, and they don't even need a SolidWorks seat on their computer. The file types are vast. There are a few CAD-specific file types like ProE and Inventor, along with, of course, SolidWorks, but you could also read in a few neutral data types if you need to get other deployable or descriptive information from places like maybe the 3D Content Central or GrabCAD websites. So a lot of that great information is out there. When you open up the SolidWorks file, it brings in all of the properties. So any of you that are utilizing data management systems where you're capturing data cards full of information, those types of things pull directly into Composer. So there's no need to reinvent the wheel to capture that information and potentially have a typographical error which leads to miscommunication, and we want to avoid that whenever possible. When you open up the SolidWorks file, it actually reads in the tree exactly as it was in SolidWorks. You can even see the colors on the screen, the assembly position. All of this information is available directly inside of Composer. Now we take this information and we use it to create what we call views. Now views can be a lot of different things. Views can be basic snapshots where you have parts and assemblies in a particular position. I like to create views like my bill of materials view here where we simply reposition the parts and put some notes next to those. But it's all about capturing the information that we want to convey to somebody. And doing it in individual pictures is fine, but when you have a static image and text, you isolate who can actually utilize that. Static images being fairly universal, but when it comes to text, not everybody speaks English, so we want to be able to have this have a universal appeal. So creating data is a very simple capture operation. In many cases, it's a matter of grabbing geometry on the screen and doing simple things like translate and rotate. You can pull parts and push them into different positions, and this is a lot like capturing configurations in SolidWorks. However, there's no need for those excessive additions to your file size, which is what configurations do there. And it's also very simple just to capture things, and it grabs whatever is in the frame. What's hidden, what's shown, what position these files happen to be in. So when I want to add additional data, it's very simple just to snap to the geometry, grab on what's there, and maybe go ahead and show exactly how this part is going to be assembled. And these types of elements also are changeable, just like the CAD data that we bring in. You can pick and drag them around. You can easily go ahead once again and snap to geometry, position these things in 3D space. And by doing this, you're basically creating what we try to do in a very manual process using a tool, say like PowerPoint. These are completely 3D, so any changes I make to my view position, the arrows update very dynamically. So tweaking a little bit of a viewpoint there is a simple thing to deal with. We update our views when changes are there. You'll see that the new captures over there grab all of that information. So what we basically did on that one is we showed you how we opened up the CAD files directly. And SolidWorks will be the wheelhouse for this, but of course other CAD data does exist in the area. So you'll want to be able to bring that in as well. Everything that you built in the CAD system, the position of the parts, the colors, the views, all of that information is going to come directly across from the CAD system. So again, no need to recreate that or try to build something from the ground up that mimics what the CAD data is. It's very simple and quick to do this, and it doesn't require the types of steps that you'd use to turn off mates or hide and show components strategically like you would in SolidWorks. And animations happen automatically from view to view. So as I capture these changes, I get a very nice transition that we call tweening that essentially shows you the difference from one view to another. The next portion of this, we talk about a little bit of the animation and the changeability. And I'm not going to demonstrate these live, but I do want to show you some of the results of each of these. We say an animation is a powerful thing because a picture is worth 1,000 words, but an animation to me is worth 1,000,000. Doesn't matter who sees it, it's very visually appealing. And again, once anybody sees it with different language capabilities, it's a universal type of a thing, so we don't have to worry about that particular challenge. Also, when you change something in the CAD system, geometric changes can be assimilated into Composer fairly easily. When you change the assembly or the parts, we deploy a change operation which then updates the geometry inside of Composer. Now what this also does is it takes every single snapshot, all of those views that we created, and it will capture and update each of those as well. Now when we're looking at these things over in our Views tab, any geometric change to the CAD system is going to affect whatever view a part might be visible in. So here we might change a battery terminal or how these parts actually go together. And once again, you can see that there's some great animation that happens from one view to another when we're talking about what happens from one view to another. So here I'll show you this little animation right here. Simply taking these static views and moving those together. But the CAD files will trickle in and update, and no need to recreate each of these views in order to go ahead and capture those. So essentially the animations describe things in a very universal way. Now, minimal text is always my goal. You're still going to need some, but we want to make things as discoverable and easy for any end user that might imagine it to, we might imagine to pick this up. Changes in CAD are updated in Composer, and we don't have to reproduce things from the beginning. Now, to save these files out to other people, we still want to be able to give them in a way that's a very universal method. So PDFs are one of the ways that you could output files. Producing high-resolution images that actually are used in your existing publishing tool is also a very common way to deploy Composer. Saving out high-resolution raster images or vector-based technical illustration images allows you to use the tools you might currently have, like Publisher, maybe even Microsoft Word, or things like InDesign and Adobe Illustrator for those types of purposes. We can also produce things out as full animations. So when we're looking at this information, we can play it on any electronic device because animations are something that you can play no matter what the operating system happens to be. One of my favorite tools is actually using the SolidWorks Composer player, which is a 3D deployable viewer just like the eDrawings viewer. It's 100% free. You can not only bake it into the file type itself as you save it, but you could have somebody simply go to your website or the SolidWorks website and download and install it for perpetual use. When you're saving things out of Composer, we can produce these things to any one of those types. So whether we happen to be looking at a file that's going to go into a Word document, and we'd see that deployed here with imagery, this image is saved out of Composer and simply embedded with a link into Word or any of the other applications. That also has to do with the changeability. So if we change the Composer file and update the images, the Word document, the InDesign file, all of those would update also. I really like to deploy this using the Composer player because it allows us to give this file out in a very simplistic way, but build in navigation just through the way that we create those views and link one to the other based on captures. So this is the type of file that you can deploy to anybody with a computer, and they will be able to see in a very descriptive way how these assembly steps proceed. And I can't imagine anybody that's going to be in any type of visual or engineering type of a capacity that would have difficulty assembling components, seeing these types of steps laid out for them. Now, near the end of this animation, I also play a little bit more, which really shows how this entire device actually gets deployed. Now, when you're dealing with these types of things, you can use the views inside of the Composer player, and you can really jump to almost any step that you'd like to. But by using the on-screen cues that you create, or the ability to go ahead and maybe modify what we're seeing here on the screen, we'll be able to go ahead and animate this for any user to show them how the assembly steps or how the adjustments of a component like this are going to work. So many ways to produce these files, whether it's high-resolution images to be used in your current desktop publishing application, videos to play on any device or web page, or the Composer player for free and interactive experiences on touchscreen computers, Microsoft Surfaces, any of those types of things. So a lot of great ways to send these files out. So in summary here, showed you how to capture the data by opening CAD files directly. You're going to have all the visual properties and positions set up in SolidWorks. And then you can go ahead and describe how these parts go together by sort of working in reverse and building these views and snapshots. The ability to animate and change these files is key because we want to be able to deploy these in a universal way, but when change happens, we need to assimilate that very easily. So updating the file from the CAD system is an integral part of these steps. And in the end, you can produce and deploy this any way that you're comfortable, whether it's using some one of your existing methods or embracing some of the more interactive and dynamic methods that we use to deploy this information. So the next thing I want to talk about here is SolidWorks Model-Based Definition. Now this is a somewhat of a new application when it comes to SolidWorks native tools, but Model-Based Definition is actually something that has been around for quite a while. Now what is Model-Based Definition? Well, basically think about a part like this. We go ahead and take this part that we're intending to manufacture and we essentially go ahead and create it in 3D CAD. Now in 3D, that file is then taken from a billet of aluminum, we machine it in 3D, and we end up with a 3D file. But all along, we've always been using these existing methodologies, taking a 3D file and flattening out into this 2D communication tool. We've been doing that for years. Well, why not just take your 3D file and also annotate it in a 3D way. The way that's more universal, it's more visually appealing, and we're not having to duplicate efforts by making a 2D drawing from something that's 3D so that we can convey how to build it back in 3D. Now the process itself is very expensive to make drawings. In fact, the Secretary of Defense did a study and they found that they spend a third of their time making 2D drawings, and more or less just because we've always made 2D drawings from the drafting board era and up. Yet 60% of these drawings simply don't match the 3D files that they are meant to represent. And you know, the tools in SolidWorks make this a difficult process, but it's still something that can be done. Whether it's a file that's out of date and uncontrolled, or whether it's just simply not using the tools properly to manage file references and having these things give you bogus information. And that is obviously very expensive, not just because a third of a user's time is meant making these documents, but that 60% of them don't match is going to create scrap, and that's pretty devastating. So they also did a study here, and this was an interesting one. I love this slide. The study was done by BAE Systems, and it had to do with this troop personnel carrier versus the documentation used to represent that troop personnel carrier. And what they wanted to do is actually see which one weighed more. Well, in the end of this, once they weighed them out, all of the spec manuals, mil specs, documents for creating and manufacturing these files, they actually found out that the pile of paper was heavier than the actual military vehicle. Now that's pretty telling. We're making a lot of paper in technology times that really don't require anything in that type of a format. So what I want to show you here is really just the two aspects that we use for model-based definition. First thing we're going to do is capture the information from your 3D SolidWorks files. Now the animation or the annotations that we use, dimensions and features and sketch values, are something that we build. And we build them for parametric change. So as you add a sketch and you essentially dimension it in a very much of an isolated situation, that's not really with manufacturing in mind. It's more with changeability in mind. So we're going to capture the dimensions that we need to scheme this for full production level creation. And then I want to show you how to communicate those files out to anybody that might need to see those. So first let's go ahead and capture. I'm going to move back over to SolidWorks for this one. And I want you to see that because we built a 3D file, there's really no need to flatten this. And we can literally go into a drawingless type of a situation. Now, drawingless and paperless are two different things. We have lots of paperless techniques, but this one is literally drawingless. When we're dealing with this file in SolidWorks, using model-based definition, I can go ahead and capture different standard views just like we would on a 2D drawing, but we still give everybody the ability to see these in their 3D positions. I can rotate these files around. I can even have the annotations show up only when that view becomes fairly close. It's a really neat tool for this. Capturing the information is actually quite simple. All we're doing in 3D is just adding location and basic dimensions. When you grab on edges or faces, it applies the dimensions and whatever tolerance you have set up in the system. You can even go ahead and apply the basic dimensions through this method. So if we want to go ahead and grab the location of a couple of holes, that's going to give us the appropriate type of tolerance that we would use for that as well. You can see that as I go back to the isometric view, we have a very nice view there, and those additional dimensions are going to show very nicely for us. Now over here on the side, what I also want to do is show you a little bit about some of the assembly capabilities that are available here with this as well. Whoops, excuse me. We'll stay inside of SolidWorks for this one. When dealing with an assembly, our view capture has the ability to do a lot of like what you just saw in Composer. Be able to zoom in and hide and show parts in different situations, but add those dimensional values that we need for any position that's important. Now over here on this assembly, what I want to show you is a little bit more to this is in these orientations. Many times what we need to do is dimension the stack up of how an assembly actually goes together. So in situations like this, we want to be able to apply these dimensions in the same way. So here we can simply grab holes, scheme this thing in 3D, and as we do that, it's going to apply a dimension in whatever orientation we snap our cursor. That dimension is now visible in all those 3D views and the main view here that we activated in order to go ahead and create this. Now each of these views is something that we're setting up essentially to be utilized in the downstream communications tool. But as we're creating things here in 3D, we have the ability to depict these. Now we also get a great little bit of talkback. When you hover over an annotation like this GD&T control frame with the position tolerance, you'll see in the lower right-hand area here that it actually shows you the XYZ origin that that's based on and gives you some positional orientation based on these types of inputs. So it's a pretty interesting way to be able to see this once again in 3D. Now not everybody has SolidWorks, and that's where we have to then go ahead and deal with how do we get this into the hands of everybody else. So here we've captured PMI data, which is the term that's used industry-wide, to grab this product manufacturing information, GD&Ts, datums, proper dimensions with tolerances, and be able to add those to the 3D model, therefore bypassing the need to make a 2D drawing from this file or the assembly in that matter at all. Now communicating this out to somebody is really the key, because essentially what we have to do is not only capture this, but give it to the people who don't necessarily have SolidWorks available to them. So when we're dealing with the communication process, we're really just kicking out files directly from MBD inside of SolidWorks. Down here in the bottom you can see that I can kick out PDFs or e-drawings, and either of those, again based on your audience, is a choice. When you kick out something like a PDF, we can go ahead and deal with these templates. Now we give you a bunch of templates to go with, but some of you out there are ambitious enough where you want to customize it with your own logos and maybe put property fields in there that are important to you. The template editor is a single button pick away, and that allows us to go ahead and actually put in things like generic tables and other things. So if I want to add a table or some text to this, I just go ahead and click on that table, I grab the type of title block or table text I want to put in there, and then that's going to go ahead and insert that particular feature. And it gives me a nice update here where I can control where bill of materials information is, where properties go, and I can even have multi-pages on these templates. Now when I go ahead and actually put these template views in place, we can then kick this file out to a PDF file, drop it anywhere that we'd like, and go ahead and save this document. What it will automatically do is then create the PDF from the snapshots that we see here on the screen, and it will drop them into the different viewable panes that are on our PDF template. Now after a few seconds here, this PDF is going to open up automatically. I'm going to jump to the end here just a little bit. But what you'll see here is a fantastic looking file that has, once again, universal appeal. Users can see the properties that are automatically pulled from your SolidWorks files. Notes, windows, and other bill of materials information can also be positioned on this file. Here's the one that I just created, popping up live for us. When you select any window down here from the thumbnails, these are automatically 3D viewable. We can zoom and rotate and pan by using different combinations of mouse buttons and the middle mouse button. This also has talkback though. Talkback is a tremendous thing. When I select on a dimension, it highlights the features that that dimension is actually related to. So when we move to different positions and we start to zoom in, you'll notice that as we start clicking on different things here, that the actual faces of that particular feature are highlighting with that talkback. So users that are downstream, that might be in quality control or manufacturing, can utilize standard PDFs in order to see these types of views. Now on page 2, I actually had a couple of 3D views and a bill of materials pane there. Each of these 3D views can be displayed independently, so if I want to show the entire frame and maybe a wireframe look, I can see different types of displays, as well as getting feedback here, where as I select components, it's highlighting that component in the bill of materials below. And it doesn't matter which view I select that in, or if I select in the bill of materials, it actually feeds back and shows up in the view windows here. So we can use both of these views side by side and see that interactivity dynamically. Once again, eDrawings is also a deployment tool. eDrawings would use more of standard layouts where you'd have the views across the bottom and the other types of additional things that eDrawings does, like dimensioning, standard views, once again, being able to see tooltips on the parts themselves. So whatever your deployment tool of choice is, that's the one that you're going to want to go with when we're talking about sending out model-based definition files. So essentially PDFs or eDrawings are universal deliverables. Of course, PDFs being out there for everybody, and eDrawings are huge in the SolidWorks community as well as peripheral CAD communities. Utilizing CAD data with other departments that maybe don't have access to the SolidWorks data, it's a tremendous way to be able to get quality control on board without giving them an intimidating user interface or something they're not used to seeing. And mainly, it reduces the need for 2D drawings altogether. If you ask yourself the question, am I making 2D drawings because I've made 2D drawings forever? Or am I making 2D drawings because they are the best way to communicate with my people? And that's one of the things that I struggle with the most these days, is I feel that 2D drawings are one of those dinosaurs that we've done forever. And we don't necessarily need to do that. It's just because we've always communicated that way. So if we have some like-minded people that would like to embrace more dynamic ways to communicate, I think you're going to find that it's not only easier, but you're also going to get better quality and better products and maybe better morale. Just we're not looking at these old archaic 2D drawings anymore. A lot of people have difficulty interpreting 2D drawings, and even people in manufacturing, which kind of goes against the whole purpose. We're trying to tell them how to make things. Let's do it in a better way. Skip those extra steps. Save your engineering time and budget. All right, so next we're going to move on to inspection. But before we do that, why would you do this? Now, I mentioned those questions you want to ask yourself. Why would you want to go to model-based definition? Well, the Department of Defense, Secretary of Defense I mentioned before, they've been doing this for a long time. Their goal is to not really worry about what CAD system people create geometry in. Their goal is actually to make the deliverable a PDF with a 3D neutral step file in it and all of the universal annotation that would be necessary for anybody downstream to be able to manufacture from. So they've been pushing this for a while. It's just going to get to be a bigger and bigger and more common thing. All right, last we're going to cover SolidWorks inspection. Now this is one of those tools where we really take a very manual, very time-consuming, and extremely error-prone process and really boil it down to just a matter of a few button clicks. SolidWorks inspection is used to capture balloon information, to report these to anybody downstream, like quality control once again, or manufacturing, and then be able to use those measurement devices that are used in quality control to maybe feed back the information that they get off of the actual manufactured components and the lot size that they chose to inspect. So it's a very straightforward process to make this happen. First thing I want to do is show you how to capture things. Now there's actually two different interfaces for this, so let me just give you more screen space here and I'll show you both of these. The two interfaces are these. First of all, you have a standalone interface. Now the standalone interface is great because it also does not tie up a SolidWorks license. This allows anybody within your company that creates these reports to not necessarily be CAD savvy, but have the ability to go ahead and capture things. Now this utilizes TIFF images and PDF files, which really makes it CAD universal. I can use it to capture anything that I might want on the drawing, so if I'm just grabbing note information here, might go up to the upper corner, and just simply window select. Now it utilizes optical character recognition. So as I window select entities, you'll notice that these feed back directly into our characteristics tab, but it also automatically reads the text that's within our capture window, and it's pretty good at this. Now we do the same thing when it comes to dimensions. Great thing about this is it not only captures the values, but it grabs all of the things, like the tolerance value that we have here. It knows it's a linear dimension, the value of it, even gives you the arithmetic on the plus and the minus values of the tolerance. So whenever we're utilizing standalone inspection, it's really just a matter of going through this very simple process of window selecting the things that are important to you. We even have methods of dealing with GD&T control frames and doing nice image captures of each of those. Dimensions without tolerances can have some pre-set up logic. So a 3 decimal place dimension here has a plus or minus 0.005 tolerance as a default. Now this process is not difficult, but it is time consuming because we're sitting here manually selecting all of the dimensions that are necessary within this drawing. But every type of dimension, as you can see, different types of tolerances are all retained and grabbed within this tool. When we move over to SolidWorks, however, the experience becomes quite a bit different. With SolidWorks, we open up your SolidWorks native drawings. And of course, a SolidWorks native drawing is going to have intelligence to it. We're aware of the dimensions, we know where they are, we even know where the notes are. So to do the capture process inside of SolidWorks, it's really just a very simple 3-step process. We use a template that's going to have some pre-set up logics and defaults. We have several that come with the software. Here we can go ahead and capture properties like part number and part name by linking directly to the properties from the parts themselves. This makes it very easy when changeability happens because now we're talking about associativity, not just a graphical capture. As we move forward, we can choose what entities are actually inspected. So I'm going to grab all the dimensions, even a few of the notes. You can even have sheet level notes, notes that are going to be down in your title block there. And then there's the logic for how these actual dimensions that maybe don't have tolerances applied will maybe have a dimension or a tolerance applied automatically. From there we just say go. And when you click the green check mark, you just sit back watch all of the balloons show up. Now each of these balloons gets automatically attached to the annotation that they are relative to, but they're also all put on layers. So you don't have to have a view here or a drawing that gets messied up because of this. You can see that the balloons actually get created on a layer that can be hidden and shown quite easily. Now the dimensions themselves are interactive, so as I select them it brings up the properties for the bill of characteristics and the dimension that you're talking about. And you can choose to not include a dimension if you'd like, and it will simply renumber for you automatically. Or you can add dimensions after the fact and have the same type of appeal. Here, by simply adding it back in, you'll see that my numbers will now resequence as a result of that. We can clarify by adding additional things about a dimension, maybe triggering as a key dimension, which here you'll see the type of balloon actually change as a result of that. Oh, I didn't grab that dimension there. I grabbed a different one. Let's grab this one here. How about that? Now you'll see number 15 here actually change to a flag type of a balloon. Or even the type of inspection tool that might be used downstream in order to go ahead and actually validate this. Maybe we're going to go ahead and use digital calipers, or CMM machine. Maybe you're just going to indicate these manually, or depth gauges. So all these types of things can be selected as your deployable type of a tool. But the capture is immediate, it's automatic, and it's very, very user-friendly at that point. So whether we're capturing these in the standalone application using TIFF images or PDF files as the input, or using it inside of SolidWorks, which does the same type of a job in much fewer steps, we can capture the characteristics easily and automatically format these to be ready for the next step, which is reporting. Now the reports that get generated out of this are based on a format called AS9102, which is a standard that creates the first article inspection documents. So here I have that represented in an Excel spreadsheet. There's 3 tabs to this, or 3 forms. First form is more or less input data, which is going to be properties and other information. The last form, which is the most important, is going to be the characteristics, whether it's the input of the dimensions, the GD&T frames, and all of the arithmetic that's necessary for that as well. In either method, we simply go ahead and create this by just simply clicking Create Excel or PDF. Now by doing this, what it will do is take all of the characteristics that we've built and build a fantastic PDF file directly from this with all of the balloons, or an Excel spreadsheet that's then going to head and going to capture and categorize all of the balloon selections that we've done in the standalone application. Using this tool in a manual method, if I see that I have a 0.325 tolerance with a plus or minus a 0.02 on that, if I type in, say, 0.315, well, that makes that dimension right down the middle. And using different templates can have different types of data validation to show you color feedback for each of those. I'll do that in the next one. Inside of SolidWorks would be the exact same process. As we're sitting here looking at our drawing, a simple click allows us to export this to Excel. AS9102 is the template that I prefer to use, and that will then once again generate an Excel spreadsheet directly from this file. The data that we see in that spreadsheet once again has the same types of values, plus or minus dimensions, and even the tolerances between each of those. So if we do a 0.755 in that one, we see that that's green because it's right down the middle. If I do a 3.1 or 3.2, that's outside the bubble, therefore that's showing up as red. Saving this off as a PDF gives us a nice ballooned version of what we see right here. So if I go ahead and create this PDF file, we'll see a beautiful representation of the SolidWorks drawings. But in this case, we're going to go ahead and see the PDF version of each of those. I threw that onto my desktop, so let me just go ahead and open that up for you. This PDF is created with multi-sheets, and we see once again all of those balloons are there and ready to be interpreted by somebody downstream in the process. Excuse me. So Excel and PDF are the files that we create automatically. They automatically format to the AS9102 standard, and we can utilize the CAD data in other departments using these very common file formats. So I think you see the theme here between inspection and Composer and model-based definition, that we're deploying these things in a very common method that's not intimidating to those downstream users. The last part here I want to show is the verification. Now this is a feature that's only in SolidWorks Inspection Professional. Now Inspection Professional is in the standalone application, but this allows us to go ahead and trigger some additional types of inputs. So down here on my table, by turning the measure tool on, I have the ability to actually go ahead and measure these things live in line. So once again, if I see that this is a 0.345 upper and a 0.305 lower, if I say 0.325, well, that's a good value. And it color codes it on my inspection capture and also allows me to see that over here in whatever lot number or item number I happen to be inspecting. If I do one that's outside the range, then it's going to give me red. And if I'm right on the edge, let's do another 0.7, it'll give me a yellow in this case because that's going to be within the tolerance band but not quite right down the center for what we need. This information can be input through digital calipers, which is a simple USB input to a pair of calipers. As you put the calipers on the part and simply press the button, it would input this value directly into this box. So if you can avoid any type of potential fat fingering and typing errors, that's a great way to do things. What we also have is the ability to go ahead and take this information and input this from an actual CMM machine. And those CMM machines would format their data out in a proper method, and that formatted data would then be used to automatically input and link to the characteristics in a particular order. I'm just going to bring that up for you quickly here. So this input would allow us to go ahead and bring in these files from the CMM machine if available. These happen to be PC DMIS, but if you have formatted files from other machines, you do have the ability to choose which CMM application you're utilizing. Now again, these have to be properly formatted, so there can be a little trial and error to set these up, but we do have a lot of the formatted frameworks up for most of the common things like FaroArms, Metrosoft Quartus is a big one out there, Calypso. Those are very common. So this will take this data here and automatically assign it. And we like to assign this using as many pieces of detail as possible, but that would then put in those informations and follow them up with the proper types of values next to the dimension that they match, both nominal, tolerance, and upper and lower limits. So when we verify things, we're inputting the dimensions from whatever the inspection method happens to be, whether it's a simple pair of digital calipers or a depth gauge, whether it's manually typed in, or whether it's a coordinate measuring machine feeding back an entire measurement scheme directly into SolidWorks Inspection Professional. So in the end, we capture information by capturing the characteristics either using window selecting and optical character recognition in Inspection standalone tool, or automatically capture those in a very easy process using the methods that we have inside of SolidWorks itself. The reports are generated in a common format specified by the AS9102 standard. It's either PDF files to represent the drawings with their balloons, and then the necessary Excel spreadsheets with the first, second, and third forms for that first article inspection document. Again, this is a method that allows us to deploy CAD information to other areas of the company. They don't need SolidWorks licenses, they really just need a computer, and that's it. And then we can verify the information once the CMM operators or the quality inspectors have verified these values. We can input that data back into the standalone SolidWorks inspection tool and be able to verify whether manufacturing actually met the mark on all of the products that you inspected or created 2D drawings for. So sort of wrapping this up a little bit before I open it up for questions. The trifecta here is SolidWorks Composer, SolidWorks ModelBased Definition, and SolidWorks Inspection. Now when we're talking about what each of these does, SolidWorks Composer is great for reusing CAD data to create documents, tech pubs, and interactive guides. And it also can capture assembly steps and easily deploy the knowledge and the proper order of how the creations and designs that you've made in SolidWorks should be physically manufactured and what order they should be assembled. SolidWorks Model-Based Definition allows us to skip the step of making 2D drawings in the event that you really are just trying to deploy this out to somebody who's going to make a 3D part anyways. So add the PMI data to the existing 3D file and stop that duplicate effort of then flattening it to 2D only to then have somebody reinterpret that to make those files 3D in reality. And then SolidWorks Inspection. This allows us to go ahead and automatically capture the characteristics from a SolidWorks drawing or any CAD file using PDF or TIFF images and easily create the ballooned PDFs and first article inspection packages that are necessary for these types of inspection situations. So with that, I'm going to end by thanking everybody for spending a little bit of time with us today. And we're going to go ahead and move over to our questions tab and see if we have any questions available. All right, I am not seeing any questions come in here. So I really would like to again thank everybody very much for spending your time with us this morning. We're going to place this on our website once again, so you'll be able to see this at a later time in a different pace, or give the link to a colleague so they'll be able to go ahead and see what we're up to. So once again, I'm Darren at DASI Solutions. I really want to thank you once again for spending time with us this morning and learning a little bit about the technical communications tools that SolidWorks has had for quite a while in our tool. If you have any other questions, please feel free to get a hold of us either through our help desk or through your sales representative, or by sending me an email directly. I'm Darren at decide-solutions.com. So go ahead and follow me on Twitter. Check out our YouTube channel. We're putting information out there constantly. And if you have any suggestions or requests, I'd be glad to hear those and deal with some digital content for those as well. So again, I want to wrap up today by saying thank you very much. Have a great afternoon, and let us know if there's anything else that we can help do to show you how to leverage your CAD data in other areas of your company. Thank you.